The last video explained the differences between a circular approach in general and circularity in the built environment. At this point, we need to establish a theoretical framework which will become the basis for the next weeks. But before we can define the key terminology of a circular built environment, we need to spend some time understanding the life cycle principles of the linear economy when applied to the field of building construction. Then we will discuss what a transition towards a circular economy means. Today, product life cycles are a widely discussed topic. Here we want to show you a simplified model. We can identify 4 phases. In the first phase, building components are produced. We talk about construction when a building is assembled on-site or prefabricated off-site. The use phase includes the whole building operation. Let's note here that this phase is by far the longest in the overall lifetime of a building. The first 2 phases may take 2 to 4 years from the first design until the building is completed. Building operation, on the other hand, lasts from 40 to 60 years or longer. We dedicate the last phase to the end of service of a building part or component. Let's go a bit more into detail. Typical activities can be allocated to each of the phases. It starts with raw material supply, transport and manufacturing of products. This is followed by more transportation activities and the on-site construction and installation. During the use phase, we refurbish, repair and maintain buildings. In a moment we will talk more about the definition of these terms and how the activities can be distinguished. Finally, the waste management is a central activity of the end-of-service phase. That would also include waste resulting from activities in the use phase. Let's note here that the linear economy has only 3 real options for waste management: recycling, recovery of the energetic value of the materials by burning them, and landfill of discarded products. In all options, a lot of the value that was introduced in the creation of products and building components is lost. In this course, we also want to highlight the role of design and management of products, buildings and cities, and the different stakeholders involved. On the supply side, we can find system provider and builder. On the demand side, building owner and user. Finally, numerous stakeholders are responsible for design and management of buildings. We can certainly come up with more design and management activities, but let's leave it at that for the moment. You can imagine that the interaction of those stakeholders requires a complex communication procedure, and a well-integrated approach is needed. But at the same time, it is very difficult to achieve. Before we discuss the circular built environment, we need to understand what circular economy means. Whereas the traditional linear economy is based on a take, make, dispose model of production, the circular economy is a regenerative approach, aiming at minimizing resource input, waste emission, water and energy leakage. This is achieved by slowing, closing and narrowing energy and material loops. It tries to avoid disposal and loss of economic and ecological value. If we go back to the life cycle phases discussed earlier, in the ideal circular model, they would be arranged in a circle with the aim to minimize waste and system losses. Along these 4 phases, there are 3 basic approaches to create a more circular built environment. Let's go more in detail in the following slides. Smarter material and product use and manufacture is the most circular level of strategies. It starts with refuse, to make a product redundant by abandoning its function. With rethink, a product use can be more intensive, for example by sharing it. Reduce means to increase the efficiency of a product by using fewer natural resources. There are 5 strategies to extend the lifespan of components, buildings, and closing the loop of energy, waste and water cycles during the construction and the use phase. It includes the strategies reuse, repair, refurbishment, remanufacture, and repurpose. Finally, useful end-of-life application of material and components is the lowest level of circular strategy. Recycling is defined as a separation of a product into its core materials and using those to substitute raw material inputs. The second option is the recovery of the energetic value of materials by burning them. Landfill is not an option in the theoretical framework of a circular economy. The complete description of the strategies can be found in the additional information section at the end of the week, where we have included a copy of the original source we are referring to in this framework. We ask you to read it carefully. The before-mentioned circularity strategies have to be implemented in the very early stages of a project. Therefore, design has a central role as an enabler of a circular built environment. We want to highlight a number of design strategies. On the product and building level, the typical design approaches are design for disassembly and design for remanufacture, reuse and recycling. On the urban and regional levels, we talk about design of a circular territorial metabolism, or for example of design for adaptive multifunctional open spaces. Finally, we want to draw attention to an ongoing discussion about the relationship between sustainability and circularity. According to the common definition of the World Commission on Environment and Development, sustainability is a development that meets the needs of the present without compromising the ability of future generations to meet their own needs. In the context of the built environment, it has sometimes been reduced to the topics of energy consumption and carbon emissions. The circular built environment approach is not contrary to the definition of sustainability. Rather, it can be defined as a way to reach sustainable development goals based on business models that aim at reducing waste by reducing, reusing, recycling and recovering materials in production, construction and during the use phase of buildings. Although it must be noted that the solutions applied can sometimes be conflicting. If, for example, you want to make a building component more modular to make it reusable, this could lead to a more complex construction with higher overall carbon emissions. Now you have been introduced to the basic terminology of the circular built environment. In the following weeks, we will be coming back to it, and I can promise many interesting examples in which we will outline the practical applications of this theoretical framework.